Good morning, guys. Welcome back to another video. We finished up all the things we need to do in chapter 8. We are talking about chapter 9 and doing some things with the quadratic formula, then doing some things with quadratics that we didn't do in chapter 8. Kind of an extension on the things that we did in chapter 8. So let's dive right in. In notes 9.1.2, we have an introduction to the quadratic formula. Maybe some of you guys have seen it before. I've been told by other students in the past that they talked about it in 7th and 8th grade, so maybe you've seen it before as well. So what does it say? 9-13, the quadratic formula. One way to calculate the roots of a parabola is by using the quadratic formula shown below. So first thing, what are roots? Well, roots are the same things as x-intercepts. They're the same things as the solutions, the zeros, the roots. These all mean the same thing. And here's the quadratic formula. It says x equals negative b plus or minus a big square root b squared minus 4ac all over, so divided by 2a. Now, at first glance, a lot of students will say this looks really intimidating or really scary, but you'll see that it's a formula, and formulas are really easy to use. All you have to know is what to plug in, and then you plug it in, calculate the number that comes back, and go from there. So it's really not going to be that bad, guys. So what does it say? In part A, when the quadratic equation is written in standard form, it looks like ax squared plus bx plus c is equal to 0. Now we know this. We know standard form goes in highest to lowest order of exponents. Here you have ax squared, that's the biggest exponent, x squared. You have bx to the first, and then c by itself, which is a constant. So standard form, a is the number of x squared terms, b is the number of x terms, and c is the constant. So all we have to do is steal a, b, and c from this right here. So a is always in front of x squared, b is in front of x to the first, and c, the constant, is by itself with no x's. So it says here, if we have it in standard form, x squared minus 3x minus 7 equals 0, then what are a, b, and c? So I know that a is supposed to be in front of x squared. What number is technically in front of x squared? Well, a lot of people say 0. But it wouldn't be 0 because we know 0 times anything would be 0, it would go away. Instead, we know that if this x squared is here, it has to be a 1x squared. So then we would know a has to be 1. What about b? Well, b is in front of the x term. What number is in front of x term? Negative 3. And then how about c? What's the constant? Well, this is the part, negative 7, that doesn't have any c's on it. So then c would be negative 7. You see, just that easy, guys. Once you know a, b, and c, now I'll show you what you can do with them. So it says the quadratic formula calculates two possible answers by using a plus minus symbol. This symbol reads as plus or minus. It is shorthand notation that tells you to calculate the formula twice. Once with addition and once with subtraction in the numerator. Therefore, every quadratic formula problem is really two different problems unless the value of the square root of b squared minus 4ac is 0. So again, here's the plus minus idea. If we go back to the formula, we have negative b plus minus this square root. So we need to do negative b plus that. That's going to be one of the calculations we need to do down here. We also need to do negative b minus the square root, which is the second calculation here. So there'll be two calculations that we need to do. All right, I'll fold this over so we have a little bit of space to work. All right, so what does it say in part C? We know we have to do two calculations. Part C says carefully substitute a, b, and c from this equation into the quadratic formula and then simplify each expression to find out what the solution or the 0 would be. Okay, so then what do we say? We know a is supposed to be 1, b is negative 3, and c is negative 7. So here we go. X equals, let's do the positive one first, negative b. So we go to our b value. So here we have negative 3. What is opposite of negative 3? Opposite of negative 3 is positive 3. So we'll go plus. We're doing the positive one first. Square root. And here we see b squared. So what is b squared? Well, I go to b and I square it. What is negative 3 squared? Well, negative 3 times negative 3 is positive 9 minus 4 times the a value. The a value is 1 times the c value, which is negative 7. All over 2 times the a value, which in this case 2 times the a value is 2 times 1. All right, let's simplify it. So here I have x equals, I still have the 3 plus, let's go inside of here. What's negative 4 times 1? That's negative 4. What's negative 4 times negative 7? It's positive 28. So in this case, positive 28 plus 9 is 37 all over 2. Now, is there an easy way to reduce the square root of 37? No, but what you can do is you can make this x approximately, and then what you can do is 2 steps in the calculator. 3 plus the square root of 37. So we'll go to calculator. 3 plus the square root of 37. We'll find out what this is. This is 9.0827, and we'll still divide it by 2. So take that number, divide it by 2. We got about 4.541. So 4.541, about 4.541. And we use the little squiggly lines to show approximately, right? Because we don't have an exact answer. Now I also need to do the minus version. So then that was like number 1. So maybe we'll call this our number 1. We'll call this our number 2. So let's do number 2. So it starts off the same way. X equals opposite of b. The opposite of b is positive 3. But instead of plus, this time we're going to do minus. We still inside of here have a big square root, b squared. We did say negative 3 squared was 9. Minus 4 times the a value, which is 1, times c value, which is negative 7, all over 2 times the a value, which is 2 times 1. So we have x equals 3, but now instead of plus, we have minus the square roots. It's the same square root as we had over here, so we have 37 all over 2. So if I want to get an approximate answer, I just have to go to the calculator, but now instead of 3 plus the square root of 37, I've got 3 minus the square root of 37. All right, so I have this negative 3.082. I need to take that, and I still need to divide it by 2. So divided by 2, negative 1.541. So negative 1.541, approximately. You see, guys? And you can use the quadratic formula to solve quadratic equations, just like we've done with factoring, with the zero product property. You can also do it this way. So here it says make a graph with your graphing calculator to verify your solution. So let's do that part together. So on your home screen, if you have a graphing calculator, if not, you can just watch. You'll hit the y equals screen. The y equals screen is right above the second button. So you hit y equals. And here's where you want to put the equation that we're solving. X squared minus 3x minus 7. So again, x is right next to alpha. Then squared is right here. So we have x squared minus 3x minus 7. So we have this. And let's say graph. So we're trying to find the zeros. We're trying to find the solutions. We're trying to find the roots. We're trying to find the x-intercepts. So we said the x-intercepts were at about 4.5 and about negative 1.5. So let's check. What do you think? Is there a solution at negative 1.5? Well, if you go to your calculator, we can see right here, we have something at between negative 1 and negative 2, about halfway. There's the negative 1.5 solution. The other solution we said was 4.5. So let's check. Well, we have something that looks like here between 4 and 5, and it's right in the middle. So there's your 4.5 solution. So when you do the quadratic formula and you find out what x is, you're actually finding the x-intercepts. It could be a fast way to do it instead of doing factoring or doing things with the zero product property. So then make a graph with graph calculator to verify solution. The x-intercepts, we can write the x-intercepts match part C. Nice, guys. All right, so there's a quick couple examples. Let's keep rolling. How about example 9-14? Example 9-14 says the quadratic formula is only one of the tools that you can use to solve quadratic equations. What are the other methods you can use? What are some things that we've done so far? Well, we've done factoring. So then factoring, remember, is like the box and the x or the diamond with the multiplying and the adding. So then you can call that factoring. What did we have to use when we were factoring? We had to use the zero product property. So then you can say factoring and the zero product property. What is the zero product property? Well, it says that if more than one thing multiplies to 0, then at least one of those things has to be equal to 0. Okay, so you may be thinking, where did this formula come from? Why does it work? You can find the formula by starting with a generic quadratic and using algebra skills to solve for x. So see the math box Note in this lesson to learn more about the formula can be derived, but in chapter 10, we'll learn another way to derive the quadratic formula. So for right now, if you want, you can go online to your book and you can read the math notes to see where the quadratic formula comes from. Or if you wait, at some point in the very near future, we will show how to do it. So what does the quadratic formula allow you to take the place of? It takes the place of factoring in the zero product property, which is kind of nice. It will save you a little bit of time if you get stuck, or if you want to check your answer, or if you want to solve it in a different way. Okay, so the last thing we have is this 9-15. I'll fold the paper over so we have some space to work. So here's just practicing the quadratic formula. We'll do a couple examples, and that'll be it. So it says, use the quadratic formula to solve the equations for x. If possible, check your solutions with a graphing calculator. Okay, so let's do it. First things first, in A, what is A, B, and C? Well, we know that a generic quadratic looks like ax squared plus bx plus c. So what is the a value in the first equation? Well, the a value in the first one is 3. What would the b value be in this first equation? It would be 7. It's in front of x. And then last but not least, what is the c value? It would be 2 without any x's. So with the quadratic formula, we know we have 2 calculations to do. So let's dive in. So first one we have x equals opposite of b. Well, b is 7. So what's opposite of 7? -7. All right. Now we can do plus minus. If you want to save yourself a little bit of time, you can do it all in one calculation. Big square roots. What is b squared? Well, I'll take b, which is 7, and I'll square it. What is 7 squared? It's 7 times 7. It would be 49. Minus 4 times the a value. The a value is 3. Times the c value, which is 2. All over 2 times the a value, which is 2 times 3. All right, we can clean it up a little bit. We have this -7 plus minus. How about here? We have -4 times 3 times 2. So if you want, you can go into the calculator. -4 times 3, or you can do it in your head, is -12 times 2 is -24. 49 minus 24 is 25. So we have this, 25 in the square root, all over 2 times 3, which is 6. Now here's where I would do the simplifying, and then you could split it up into 2 calculations. We have -7 plus minus the square root of 25, which is 5, all over 6. So then what does this mean about x? Well, we have 2 things to do. We can do it without a calculator. We can do -7 plus 5. -7 plus 5 is -2. Divided by 6 is -2/6. How does it reduce? Well, both of them have a factor of 2. You can reduce it by a factor of 2. X is -1/3. That's one possible solution. We can also do, instead of -7 plus 5, we can do -7 minus 5. So what's -7 minus 5? Well, that's -12. -12 divided by 6 is -2. So our 2 solutions are x equals -2 and x equals -1/3. Let's graph it and let's check, right? So go back to the calculator, hit the y equals screen, clear it off. So clear is right below the directional pad. And let's punch it in. Let's say 3x squared. And then we have plus 7x plus 2. Then you hit graph. We said -1/3 and -2. Well, if we look at the x-intercepts, it looks like -2 works. And it looks like -1/3, somewhere between 0 and 1, closer to 0. It looks like the 2 solutions make sense. Again, we're finding x-intercepts when you're doing the quadratic formula. So that one will be done. How about b? Let's just dive right into it. What's the a value in b? Well, the a value would be 2. What's the b value? The b value would be -9. Please don't forget the negative. A lot of people forget about it. And then how about c? C would have to be -35. So let's dive in. So if I dive in, I have x equals opposite of b. Well, what's the opposite of -9? +9. Plus minus, big square roots. What is b squared? -9 times -9 is +81. Minus 4 times the a value times the c value. The a value is 2. The c value, -35. All over 2 times the a value, which is 2 times 2. Okay, we'll simplify a little bit. We have 9 plus or minus. Let's go find out what this crazy calculation is. So then here you can put the inside of what you have underneath the square root. You have 81 minus 4. And then if you want, you can put in parentheses 2 and negative 35, but then please use the negative below the 3. And if you punch it in correctly, you'll get 361. So we have the square root 361 all over 2 times 2, which is 4. All right, so let's find out, is there a square root of 361? There is. It would be just 19. So then if I take this to the next step, I have x is equal to 9 plus or minus 19 all over 4. So we have 2 calculations to do. What is 9 plus 19? Well, that's 28. 28 over 4 we can reduce. 20 over 4 is just 7. So that means x equals 7 is one possible solution. But now instead of 9 plus 19, we can subtract. What's 9 minus 19? 9 minus 19 is negative 10 over 4. It can reduce by a factor of 2. So 2 goes into 10 5 times, 2 goes into 4 2 times. So then x would be equal to negative 5 over 2, which is the same thing as negative 2.5. So maybe we'll split up the paper a little bit so we don't run into issues knowing where our work is. So we have 2 solutions for this one. X is 7 and x is negative 5 halves. Let's check it with the graphing calculator. Let's go to the y equals screen, clear off. Let's go 2x squared minus 9x minus 35. We said 2 solutions. We said 7 and negative 2.5. What do you guys think? Did we do it correctly? Well, let's check. Positive 7, looks like if we go out this direction, oh, positive 7, we have it. Another quick way to do it is that you know this goes out to 10, so it'll be 10, 9, 8, 7. And then how about this? We had negative 5 halves, same thing as negative 2.5. We do see an x-intercept between negative 2 and negative 3, and it looks like halfway, so negative 2.5 is looking good. Okay, so we have 2 more as a bonus, C and D. So can we do it? So then how about the a value? Well, the a value is in front of x squared, the b value is in front of x, and the c value is the constant. So how about a is 8, b is 10, and c is 3? It goes in order, just like the alphabet. So let's go. X equals opposite of b, so in this case negative 10, plus minus, big square root, b squared, so what is 10 squared? Is 100, minus 4 times the a value, which is 8, times the c value, which is 3, all over 2 times the a value, which is 2 times 8. All right, so we have negative 10 plus minus. Let's go inside of here and find out what this number is. So we can do 100 minus 4 times 8 times 3 is 4. So we have a square root of 4 all over 2 times 8, which is 16. So we have x equals, we'll simplify, negative 10 plus minus, what's the square root of 4? It's 2 all over 16. So now we have 2 calculations. Let's start with negative 10 plus 2. Negative 10 plus 2 is negative 8 all over 16. What's the biggest thing that goes into 8 and 16? 8. So this would be negative 1/2. So one solution, or x-intercept, looks like it's going to be negative 1/2. But now instead of negative 10 plus 2, let's do negative 10 minus 2. So what is negative 10 minus 2? Negative 10 minus 2 is negative 12 over 16. What's the biggest thing these have in common? They have 4. So 4 goes into this negative 3. 4 goes into this 4 times. Another solution, x equals negative 3/4. So quickly, let's check with the calculator. Negative 1/2 and negative 3/4. Let's see if they hold true. So we go to y equals, no surprises there. So we have 8x squared plus 10x plus 3. Hit graph. What do you think? Do we have negative 1/2? Do we have negative 3/4? It's kind of hard to see, but you can definitely see so there are 2 things that are happening here between 0 and negative 1. It looks like right halfway, negative 1/2, and a little bit more than that, negative 3/4. So I would feel pretty confident in my answer there. All right, last one, guys. How about D? What's the a value? Well, the number in front of x squared is 1. So then a is 1. What's the b value? Well, it's the negative 5. Don't forget about the negative. The c value, positive 9. So let's dive in. X equals opposite of b. The opposite of negative 5 is positive 5. Plus minus, big square root. What is b squared? Well, negative 5 times negative 5 is 25. Minus 4 times the a value, which is 1. Times the c value, which is 9. All over 2 times the a value, which is 1. So I have x equals 5 plus or minus, how about inside of here? Here I have negative 4 times 1 times 9. Well, negative 4 times 1 is negative 4. Negative 4 times 9 is negative 36. So what is 25 minus 36? It's negative 11. All over 2 times 1, which is just 2. But how would you simplify this? Is there a square root of negative 11? Well, no, you can't take the square root of negative numbers. So in this case, you wouldn't be able to do this. So this square root of negative 11, I guess you could say, is not possible. What does that mean about the solutions or the x-intercepts? It means there are no x-intercepts. If you can't calculate a final answer for a numerical value, then that means there won't be any. Let's just check with our graphing calculator. If a parabola doesn't have any x-intercepts, should it be able to hit the x-axis? No. If it doesn't have x-intercepts, it shouldn't hit the x-axis. So let's graph and check. So we'll clear off the one that we had in there. So how about here? X squared minus 5x plus 9. We'll hit graph. Let's see. Does the parabola hit the x-axis? No, it doesn't. So in this case, will it have x-intercepts? No. Will it have roots? Will it have solutions? Will it have zeros? No. And that's exactly what the work showed here. Here we saw there were no x-intercepts because we weren't able to calculate those two numbers, and the parabola did not hit the x-axis. All right, guys, so in a nutshell, what was today's conversation? It was a quick conversation about the quadratic formula. The quadratic formula is something that can take the place of factoring and the zero product property. You can use it pretty quickly because it is a formula. Formulas are nice in math and science because formulas allow you to plug some stuff in and get an answer that might take you a little bit longer in a different method a little bit faster. So if you could try the assignment, it was a quick video today. The assignment shouldn't be too bad. Let me know what you think. Let me know if you need any help. Thanks for watching the video and have a great day, guys.